How to calculate the drag force or lift of a profile immersed in a current of fluid. In the MechAFlux software, we have the possibility of choosing two categories of object profiles. The category of geometric or usual objects, of which we only calculate the drag force. And the category of objects shaped to fly, such as wings, of which we let's calculate the drag force, but also the lift force of the profile. We are going to look at, to begin with, the profiles with drag. In the profiles with drag, we have geometric profiles, immersed in a fluid, whose dimensions we parameterize. We take here for example, an ellipsoid, 0.5 meters long, and 0.2 meters wide, that we immerse in a current of air, 80 kilometers per hour. We set the roughness, and we click on Calculate to obtain the drag force that this object will generate. We can see, in the detailed results sheet, the Reynolds number, the Cx of this ellipsoid, the drag force applied to this object, which is here 1.2 newtons, and the power consumed by its displacement in the fluid. We close the results sheet, we have the summary of the results, and, for the spherical shapes, we see a drawing, indicating the flow regime, and an estimate of the position of the separation. According to the Reynolds number and roughness. A particularly useful case of this category is the flat surface. The flat surface makes it possible to calculate the drag of friction, submerged surfaces. For example, the force of friction on a ship's hull, which would be 6 meters wide, developed, and 12 meters long, in a water current of 8 knots. With plastic shell roughness, the frictional drag of this shell is calculated. Frictional drag is the force exerted by the fluid, by friction on the plate. This result also gives us the thickness of the boundary layer, and the critical distance, where the flow changes from laminar to turbulent. This transition is depicted in this diagram. Let's continue the exploration of the geometric profiles. In the geometric profiles, we find vehicles. For example, a Porsche, with its Cx, and its master torque. We can, at a given speed, evaluate the air force on this vehicle, very simply. Here we have the result, therefore a Porsche moving at 100 kilometers per hour. Generates a drag force of 263 newtons, which consumes a power of 9.95 horsepower. Several vehicle profiles are offered. And other forms, such as the parachute. Let's dimension, for example, a parachute 6 meters wide. At 56 kilometers per hour. A parachute 6 meters wide generates a drag of 512 kilos at 56 kilometers per hour. It allows us to say that an object of 512 kilos, hung on a parachute of 6 meters, will not exceed 56 kilometers per hour. This gives us an idea of the forces involved. Please do not do any experiments that could endanger the lives of living beings to verify these calculations. Other profiles are proposed, such as the Zeppelin, or an airplane, on which we wish to evaluate the drag force generated. We come to the profiles with lift. The profiles with lift are, in general, profiles that have an aerodynamic or hydrodynamic shape. Streamlined to generate lift. The software offers profiles with lift, classic profiles, which allow us to calculate wings or foils. Here we see a NACA 0009, which is a symmetrical profile, usable, for example, to calculate the force generated by a boat fin in the water. At 56 knots, with this angle of attack, this length, and this width. This fin generates a lift force of 12 tons, and a drag force of 333 kilograms. This calculation can also be done, of course, in the air. To size wings, intended to make an object fly. A profile editor is integrated in this tab. The profile editor allows you to create aerodynamic and hydrodynamic profiles. The profile editor is described in a specific tutorial. This is the end of this discovery tutorial of the drag and lift tab.